Now in this session, we are going to see how we will be able to filter our pandas data. The moment we created a data, it's just essential to clean the data. We already discussed about this cleaning the data in the second unit. In this fourth unit also, we just do need to discuss about the filtration using pandas right now. Okay, right now how we'll be able to filter the data, let us understand. There are two ways to filter the data, just not two ways, there are many ways to filter the data. In those, primary important filtration techniques are column-wise filtration and row-wise filtration in a pandas data frame. Now, you know that when it comes to the column-wise filtration, we will be able to filter by feature-wise. For an example, there are some features which are unnecessary that we see. Rather, some values in some features are unnecessary, are not fitting into the data set. Then how will we be able to filter them? As I told you, this involves filtering the columns of the data set based on the names, data types or the other attributes. We just start talking about the columns here. It is commonly used to reduce the dimensionality of the data set. It's also is not trivial to reduce the dimensionality. It's very important task in data cleaning. Okay, so data set by selecting only the relevant features. We are going to select only the relevant features. The common use cases are selecting specific columns based on their names. We will be able to select only specific columns based on their names. We will take a feature name and we will select them. Either we will retain them or retain them. Okay, either we will be able to keep them or discard them. First, we should be able to understand how we will be able to select based on some condition. Condition meaning we want to retain or detain, select or deselect by using their respective names, dropping unnecessary or redundant columns. There is an age column reappears for thrice, but we will only hold one age column, right? So we should be able to drop unnecessary or redundant columns. Filtering the columns based on their data type. For an example, there is a numeric or categorical. We want to hold only numeric columns. We do not want any other columns which are non-numeric. So we should be able to understand how we will filter them based on the data type. Okay, filtering the columns based on the missing data percentage or variance. There is something called a variance. You know what is a variance? Variance is the difference from the mean, right? So by the variance or the percentage, we'll also be able to filter. We will be able to filter the columns. So for that, I'll give you an example using the pandas. I just have created a data. I created a simple data frame. Initially, what I created, I created a data. Okay, dictionary. In this dictionary, I have 1, 2, 3, 4 columns in which there are several rows. Okay. Alice is one row and Bob is another row, Charlie is another row. Okay, similarly for all, we do have several ages, salaries and departments. Now I just am passing this to the data frame. I'm passing this to the data frame. Now, I want to select some specific columns. How do I be able to do it? Now, from the data frame, I want to select by the name and age. Now, I just am doing selection. I'm not filtering or doing anything, I just am doing some selection here. In this selection, the columns with the name and age will get selected and it will be transferred to the filtered columns. Now when you print the filtered columns, you will get only the columns with the name, the columns identifies with the name and age. Only these two columns will get printed. Okay, now I would like to drop a column. How would I be able to drop? Simple, the function is df.drop. When you say drop with the passed parameters, you are going to drop the respective, the column with the name. Okay, axis should be equal to 1 because it's a column-wise axis, right? So axis 1, because see, when we delete the row, axis should be equal to 0. When you delete a column, the axis should be equal to 1. Then you should print df dropped. When you say df dropped, see, the dropped column has been transferred to df dropped. Okay, so which column has been dropped here? This the salary column has completely been dropped. Now the next thing is select only the numeric columns. I want to specify here the category is numerical columns. I do not want any numerical columns to be existing in my data set. I'll also be able to filter the columns by the data set, by their respective data set. Now the function is select D types. Okay, in the select D types, I should be able to use a parameter which is called include. Include is equal to number. Okay, once again, select D type is the function which is going to ask you to specify the data type that you do not want. The data type here that I do not want is the number. It could be any number, maybe a float number or an integer number. That column may include any number. All those columns which I do not want with numbers will be selected here. What I'm selecting? I'm only selecting. I'm selecting D types, data types with the numbers that will get transferred to numeric columns. Right then, I'll be able to drop numeric columns. What should I say? df.drop, I will write here, df.drop, in which I should say numeric columns. Okay, numeric columns has actually been selected. That just has, the columns which has, the column is going to give you a future, row is going to give you a record. Now I do not want an entire record or some values within the record. How to be able to do it? See, removing rows with the missing values. We already have seen this. Selecting the rows based on a specific condition. In a row, the age is greater than 20. I would like to select all those people, all those records which has a value greater than 30. Can also be selected by a specific condition, filtering the rows based on the duplicates. If a row is redundant, rather in a row, if there are more missing values with respect to any column, that can be selected and filtered, and sampling the slicing rows for analysis. Now, we'll also be able to select a specific portion of the row for the analysis. How will you be able to do it? Example is, now you want to filter the rows where age is greater than 30. Simple, from the data frame age, if it is greater than 30, will get transferred to something called a filtered rows. When I say filtered rows, what is going to happen? A filtered rows frame will get created through which all the rows which is greater than 30 will be passed. Okay, so just filtered rows is going to create a specific frame in which all the filtered rows will be transferred. Now, print, when I say filtered rows, that specific frame with the filtered rows will be printed. Now, I do want remove the rows with missing values. I want to remove all the rows with the missing values. You know that already, there is something called drop NA. Drop NA is going to leave the rows with the missing values. Okay, so already we have seen that. So, initially what we need to do is, we need to, here what is given is something different. I'll explain you here. Let me remove this. Here what I did is, okay, initially, let us say there is a data frame. Let us say there is a data frame. In the data frame, this is a specific record. This is a third record with RAM. Okay, in this RAM, let us say age is not available and salary is available. Now I am deleting RAM out of this. Right? I delete RAM out of this. There are two options. One is you can insert another record with all the possible values, or you completely can remove the RAM and have the other following values filling up from this RAM. That is, this third row will completely be deleted. Right from the fourth row onwards, this will continue. That means the fourth row will be renumbered as a third row. That means the entire third row will be out of the context. Right now, from the fourth row onwards, that becomes a third row. But here what I am doing is, here I am creating one more row with the David, age is none, salary is none. For an example, I just want to append name, age is none, salary is none. Initially, these values are not available. It is just none. I just am appending this. Okay, department IT, ignore index is equal to true. What is ignore index is equal to true? When I say ignore index is equal to true, understand carefully. See, this is my data frame. Now I am appending one row. Now, When I am appending one more row, one more record here, this record will have an index, right? This is a new record. Earlier, this record is not a part of, for the record with a name, which is that David, is not a part of the entire data frame. Now just I'm inserting this. Now the indexes will be renumbered, right? The indexes must be renumbered accordingly. To renumber the indexes with a new record added, we will have to use the ignore index is equal to true. Ignore index is equal to true, meaning the indexes will be renumbered along with newly added the record. Now earlier in the third place, Ram's record was present. Now in the third place, I want to insert a new record which is the name with this enough a name David. Now this David will have the number of 3, the index of 3. That is called ignore index is equal to true. Okay, and next thing is filtered NaN. Now what we do is filtered NaN, df with NaN, drop Na. That means we are going to remove all the records with Na. That means from the entire data set, wherever there is Na, that will completely be deleted. Now in that regard, this David will also be removed here. Okay, I hope you got the point. In a record, wherever there is a value none or Na, that will completely be deleted. That is what drop Na. Select rows by the index. How will you be able to select rows by the index? Simple, if you want to select the rows by the index, you need to use ILOC. ILOC, select the rows by the index. Okay. Now when I say ILOC 1, 2, 3, what will get selected? There are indexes starting from 0, 1, 2, 3. If I say 1, 2, 3, these 2 will get selected. 3 will get excluded. Okay. Print row selection. All the rows with numbers 1 and 2 with the indexes 1 and 2 will get selected. Combined rows and columns filtration, you'll also be able to combine these two techniques. So far, we filtered by using rows, we also filtered by using columns. We also can combine these two techniques together. How? I just would want to have a condition in which I'm going to filter both rows and columns at the same time. How would I do it? Now, I'm going to select the rows where age is greater than 30 and only the name and department columns. Okay. Now the thing is, I do have a data set. From the data set, there are several records where the age is greater than 30. There are several records, but I'm not going to select all the columns here. I'm not going to select all the columns here. I want to select only the columns with name and a department. From the columns, I will select only name and department where age is greater than 30. Okay, the filtered data, I'm going to take a data of df age greater than 30 and name comma department here. So here what I'm doing is, see here, age greater than 30. Okay, age column greater than 30. What am I doing here? Name and department columns will be filtered. So here age greater than 30 meaning the independent records will get selected, from which only name and department columns will only be selected and identified. So when I say filtered data, that filtered data will get all the records with the age greater than 30 with only columns, name and a department. Yep, these are the key points to remember. Row-wise filtration to handle unwanted data points, respective data points in a record. Column-wise filtration to remove unwanted features. Functions like ILOC, LOC, drop will be able to handle the data set. But always ensure the filtration aligns with the data analysis or machine learning goals. That means you cannot filter the important data simply by implementing the techniques of filtration. You cannot simply filter the wanted data. The data that contributes to the data set or the model should be retained, not detained. Okay, so these are the points to remember. Thank you.